Hello, welcome back to Oracle DBS tutorial. In this tutorial, we're going to discuss about how a client is going to connect to a database instance in shared server mode. This is the discussion that we had done in our last tutorial. In the last tutorial, we discussed about dedicated server. So in the dedicated server mode, we have a dedicated server that is responsible to handle the client request. So that means if I have 1000 clients connected to the Oracle database server, I must have 1000 dedicated server process. As you know, this is something not scalable. Okay, so this is something not scalable, and what they come up with a way that that brings to the rationale that we should have a shared server approach. In shared server, we can have share minimum number of clients per one server. Okay, so let's do an analogy again. So let's say we started with an analogy of our hotel in our last class. So essentially, right, say let's say this is an hotel. We have say receptionist are there. So let's say R1, R2 and R3. There are three receptionists, and let's say we are operating this thing in a dedicated server mode. In that case, each client is going to directly talk to a receptionist. So client 2 is going to talk to client 3 is going to talk to here. So as we discussed, this is not a scalable way. So what we can do, just assume for a moment what should it look like if I just have only one receptionist available. So if I have one receptionist available and then I have three clients are coming, in that case what happens? So if these three clients are going to connect simultaneously, then the listener is going to put them in front of this receptionist C2 and C3. That means we are going to build a line, or we are going to build a queue in front of the receptionist, and this receptionist can serve this client one also, like when this client when after serving this client one, it can serve the client two and so on. It can serve in a round robin or some kind of priority and all this thing. Okay, so let's say in case I have two receptionists, so in that case maybe C1 and C2 is going to be served by R1, and C3 may come to R3. So essentially what we are going to have, we are going to have queues. Okay, so exactly this is something happens in Oracle. In a shared server mode, we are going to have some sort of queue, and we are going to discuss all those things in a couple of minutes. Before discussing that, let's see what is the role of the listener in case of a shared server mode. In case of a shared server mode, when a request comes from the client to the listener, instead of creating a dedicated server, it is going to fork a dispatcher process. And dispatcher process is something, it's not necessarily is going to port 1 2 3 4. I just give an example, but the first step is listener is going to fork a dispatcher process, and then this dispatcher process is a lightweight process instead of a dedicated server, which is a workhorse or heavy process. Okay, so listener is going to create a dispatcher process, and then the listener is going to tell to the client, go and connect to the dispatcher process, and in step 4 finally client is going to, so let's say this is the client is going to talk directly to the dispatcher process. Then what happens is that in shared server process, in shared server mode, the dispatcher, so like let's say I have client 1 and client 1 has a dispatcher. Then let's say I have another client 2. Client 2 is going to have his own dispatcher process. And then basically we connect, we connect to the database server, and then let's say we are sending some SQL statement, like let's say client 1 is going to do select star from MP, and client 2 is going to do select star from department. So these are basically the work that's supposed to be done. So what it does is dispatcher 1 and dispatcher 2 is going to put these commands in a queue called request queue. Understand point? So in the request queue we are going to put all these commands. Then there is one shared server. So that shared server is going to look at the request queue, and then is going to take the command and going to execute, and then whatever the result is going to it is going to put into the response queue. Okay, and then let's say for example there is a client 1, client 2, these are the requests, like somebody is sending select star from MP, and somebody is doing select star from DPT. All those commands are there in the request queue. Whenever shared server is free, he is going to basically take the commands, execute, and then the return result is going to be put in the response queue. Let's say the R1 and R2 and so on, it's answer. So all this dispatcher is going to poll to this response queue, and then whenever their results is coming back, they are going to get the result and return it back to the client. Okay, so by doing this, what we solve is that we are no more, like say for example in this case we do not need any more dedicated server. That is basically if in a dedicated server mode we should have need 2 dedicated server process, but here we can get it by just using one shared server. But having said that, we saved a dedicated server process, right? But instead of that, we are going to create this complex data structure like request queue, response queue, and this small lightweight dispatcher process. But still it is this trade-off. So basically we are going to save some dedicated server process, but instead of that we are going to make this life complicated, and this coordination should happen properly. But that makes sense if we are going to have, let's say we are going to share 100 clients to one shared server, then yes. So basically in this case what I'm saying, that had I run this thing in a dedicated server mode, I should have 100 dedicated servers, and 100 dedicated server is too much compared to just one shared server plus 100 dispatcher process plus one data structure like queue. So this trade-off is definitely much better compared to 100 dedicated server processes. Alright, so this is the final picture, how it's going to look. Let's say we have a client C1. Client C1 is basically come to listener, and listener creates a dispatcher, and then dispatcher is going to put the command to the request queue, and this shared server is going to poll to the request queue, and then whenever he is free he is going to get this request queue and then execute using SGA and files and all this thing, and then when the answer is ready he is going to get back to response queue, and then response queue dispatcher is going to get this thing from response queue and get it back to the client, and C2 and C3. Let's say we have a parameter where we say how many shared server per client. Let's say we are just having 3 clients per shared server. That means when the client number 4 comes, what the listener is going to create another shared server, another request queue and response queue exactly similar to what we are showing here, and then client 4 is going to have his dispatcher process, and then client 4 dispatcher process is going to put those things in the request queue, and then this shared server is going to get that command from the queue and execute and get it out. Okay, and then this client 2 will have so another dispatcher, and client 3 will have dispatcher. Okay, so therefore what you are going to have, the summarization is that if you want to run in the share server mode, depending on how many clients you are going to run per share server, that many number of share server is going to be there. But irrespective of share server, we are going to have a one-to-one mapping of dispatcher. But remember that dispatcher process is just a dumb process. They don't do anything except they just basically accept some request and then put that thing in a queue, and then you are going to have this additional data structure which is going to manage the request queue and response queue. But this gives us a lot of performance boost whenever considering from the dedicated server.